Today we're going to actually solve for excess reactant. So remind me, what does it mean for a reactant to be in excess? What's that mean?
There's extra of it left over.
It is left over. What's the non-excess reactant called? Go ahead, say it. A limiting reactant, right? The limiting reactant is what limits the amount of product that we can make. So when I'm trying to determine my limiting reactant, right, I'm taking both of my reactants to what? I'm taking both of my reactants to, the same product, one of my products, right? And I'm going to take them to grams most of the time. I could stop at moles if I wanted to, right? If it didn't ask me a specific question, I could stop that at moles. But I'm taking both of them to the same product so that I can compare. When I find my limiting reactant, am I looking for the greater amount of product or the lesser amount of product? The lesser, right? Because I'm not going to be able to make the most, that greater amount of product, right? My production will stop after I make that least amount. So today we're going to start answering a multitude of questions now. All the problems we've done so far have really only required 2 T-charts, right, to solve for what is our limiting reactant and how much of a product we can form. But now we're going to take it one step further and talk about our excess reactants, okay? So let's start with this problem here. I already put the equation up, but the equation is not balanced. So I need you to balance it real quick first, and then we'll get into what it's asking us for here, okay? We've got iron in combination with oxygen gas that yields iron oxide. I think that we could do this without the chart, right? I see 2 irons, so I'm going to make 2 irons. What am I going to have to do here on this right side with my oxygens? Right, I'm going to have to put a coefficient there because I'm never going to have an odd number of oxygens here. So that's going to change my iron from a 2 to a 4. And my oxygen now needs to have a 3. Okay, you see how that kind of worked? All right, it tells me that I'm starting with 45 grams of oxygen. 45 grams of iron. And I'm starting with 87 grams of oxygen gas. And it asks me, what is my limiting reactant? So when I have 2 starting amounts, what's that a Q for me? I'm going to have to do what? I'm going to have to do 2 conversions, 2 T-charts from each of those reactants to a product. Now, in this case, do I have to pick my product?
No.
Because there's only one, right? I'm going to take them both to my product. So it might be helpful if we draw those arrows that kind of remind us where we're going, right? It asks me, what's the limiting reactant and what's the maximum amount of iron oxide that can be formed? So we're going to go ahead and take that to grams. How much excess reactant is left over? We'll save that for a second. So let's do what we know so far, and we're going to find out our limiting reactant. Okay, we're going to start with 45 grams of iron. I'm going to let you work through these T-charts because I think you know what you're doing there. And we'll check at the end. You could, yeah. Technically, since it doesn't ask me for the mass of my product, you could stop at moles if you wanted to. Yeah, that's a great question. You could pick moles or grams, right? If you want to stop at moles, you are welcome to do so. And then we'll just compare to see, do we have the same limiting reactant, right? Because I'm going to take mine all the way to grams. We should get the same answer. So you can stop it at moles, and we'll make sure that we do. Okay? Make sure your molar mass for O2 is 32, not 16, right? It's got to be O2. Is that what we had for molar mass of iron oxide?
159.6.
Okay, perfect. Yeah, fine. Yep, fine. Yep, no problem. Does that resemble your values? Or are they somewhere close? If you stopped at moles, right, you're going to have something different. But what does this information tell me as far as what is my limiting reactant? It's iron, right? So my limiting reactant is Fe. Okay? Now, the last part of our question asks, how much excess reactant is left over? So first of all, tell me what is our excess reactant? It's oxygen gas. Okay, so let's remember what happens in a limiting reactant type situation. All 45 grams of iron are going to be used up, right? Every single bit of that are going to be used up to be able to produce 64.4 grams. So when it says, what's the maximum amount of iron oxide that can be formed? If you have your answer in moles, that's fine. But did you still get that iron was your limiting reactant? Did it still give you the smaller amount? Perfect, okay? So when it asks how much excess reactant, we have to add one more T-chart to our situation, okay? And I'm going to give myself some room here to do that. But I'm going to put this up here so we can look at it still. Okay, what happens with this last one is that we need to do a chart now starting with our limiting reactant, 45 grams of iron. And we need to do a conversion to say, if we use 45 grams of iron, how many grams of oxygen gas does that mean that we are using up? So we do a conversion from 45 grams of iron to grams of oxygen to say, how many grams of oxygen would we use if we used up all 45 grams of iron? Okay, so we're going to go grams of iron to moles of iron. Moles of iron to moles of oxygen gas, right? That's our other reactant. Moles of O2 to grams of O2. And this one we do want to take all the way to grams so that we can compare it with our starting amount of oxygen gas, which was already in grams, okay? What this chart is telling us is that if we use up all 45 grams, which we know we will, of iron, how many grams of oxygen will be used in that conversion, in that reaction? So I'm going to go 1 mole, 55.8 grams, 4 to 3, and 1 to 32. So 45 times 3 times 32. And that, for me, gave me a value of 19.4 grams of O2. Is that similar?
Mm-hmm.
Okay. And so is this the amount of oxygen gas that's left over?
No.
No, this is the amount of oxygen gas that is used, right? If I use 45 grams of iron, it would require me to use 19.4 grams of my oxygen gas. So how can I go about finding how much oxygen gas is left over? Yeah, what do you think?
Subtract it. Yeah.
I'm just going to subtract, right? I'm going to take what I had, 87 grams of O2 minus 19.4 grams of O2. And that's going to give me 67.6 grams of O2 left over. Once we determine what our limiting reactant is, in this case it was iron, any additional T-charts we do after that need to start with 45 grams of iron. Right? Any other questions that you have to answer, once you know your limiting reactant, you should only start with that. It doesn't do me any good to keep doing 2 T-charts for each because I know that my limiting reactant is iron. So once I know that, any additional questions I have to answer need to start with the starting amount of limiting reactant. Okay? All right, very good. I want to do one more together with kind of all of the facets we've talked about. And this one I don't have in your notes. I don't have any additional problems in your notes. So just do this one. Like, I think it looks like you've got an extra little half sheet that we could work a problem on. So let's go ahead and just do that kind of in the scratch section of your notes sheet there. And I'm just going to put a reaction up on the board and we'll put up some questions about it. So let's build a double displacement reaction here. Let's try beryllium hydroxide combines with lithium nitrate, which would then yield beryllium nitrate. And then my final product would be lithium hydroxide. It will need to be balanced.
Oh, you want to give it to us?
Yeah, sorry. I'm sorry. Yeah, I was just saying it out loud as I was going. So yeah, here's your reaction. We do need to go ahead and balance it. And I think it's a pretty simple balance. Okay, because these are just 1s and 2s. And then I'm going to give us a starting amount for each of our reactants. We're going to start with 38.4 grams of beryllium hydroxide. And we're going to start with 43.4 grams of lithium nitrate. Now, these numbers and these problem is just being made up off the top of my head. So I have no idea what I'm expecting the limiting reactant to be. I have no idea if it's going to be close or not, but we're going to try it. So here's the starting information. Here are the questions that I want us to answer. Okay, question number 1 is how many grams of each product can I make? Right, and we kind of had to do this on this last homework assignment, but this is going to make us make some decisions. So how many grams of each product can I make? And then how many grams of excess reactant is there? Okay, so let's talk through what this kind of means here. All right, am I going too fast or are we doing okay? So here's what we're going to do. The first thing we've got to do, since we're given 2 starting amounts, is to find the limiting reactant, right? We have to find the limiting reactant first. So we get to pick which product we go to first to determine our limiting reactant. We just get to pick one. So it doesn't matter which one we pick. Let's just pick one. Here, 50-50 split. Okay, let's go to the first one. Okay, we're gonna take both of our reactants right now to our product, to the same product, to determine the limiting reactant. And that will also answer half of our first question. How many grams of beryllium nitrate can I make, right? I'm answering part of that question. But let's go ahead and do that. 38.4 grams BeOH2. We can kind of work together here on molar masses. So if you've got them, you can kind of shout them out just so that we can move a little faster. I don't know if anyone has those yet, but 43 on the first one.
I got 43.
I got 43.
43. Okay.
Oh, I did it for the other one.
Okay. All right, then we're going to go mole ratio.
And that more mass is
133. Thank you. So my mole ratios here would be 1 to 1, right?
Yeah. Oh, yeah, you guys are.
All right.
Sorry.
We still on the first one.
Oh my god.
No.
I confused myself for a second.
I'm not all on the second one.
No, I put a wrong number down. No, I put a wrong number down. No, I put a wrong number down.
No, I can see his page. You put the wrong number down.
All right. So I don't have that in my calculator run just yet. Do we have an answer for that one or no? Okay. So this would be grams of beryllium nitrate. Are we just trusting that we're doing it right? Did anyone else get that? Okay, very good. Luke, I believed you though. Okay. All right, next one, I'm going to take that other reactant, 43.4 grams of LiNO3. And am I going to take this to my other product?
No.
No, I need to take it to the same product.
I got a molar mass of 69. Add it to.
On that first one? Thank you. LiNO3, BeNO3, 2. And on the last one, we know our molar mass is the same. So mole ratio here is 2 on the bottom to 1 on the top. Are we going too fast or are we doing okay? Going too fast? Okay. So Macy just asked that question I was going to talk about here, but we've got our limiting reactant. We know our limiting reactant is lithium nitrate, right? This answers half of my question. I can form 41.83 grams of this product, right? So that answers half of my question on number 1. The other part of my question says how many of each product. So I still need to figure out how many grams of lithium hydroxide I can make. Now, do I need to do both T-charts again to lithium hydroxide? No, because I know my limiting reactant is this. So I'm going to start again, 43.4 grams of lithium nitrate. And this time I'm going to take it to my other product with this lithium hydroxide. Okay, so we've already got our molar mass for that first one.
Wait, I have a question.
Uh-huh.
How do you use the limiting?
All right, so my mole ratio here would be 2 to 2. Is molar mass what, 24? Or could I not do math? Is 24 close? I put lithium to 7.
Oh.
So 7 plus 16 plus, yeah, 24. Okay. So now I'm at a place where I've answered the first question fully. I've got an amount for both of my products, right? It says of each product. Now, it's so important that you give me a final answer. Doing the work and then just leaving your T-charts like this is really not an acceptable answer. And I noticed that on some of your homework was that you would just do the work and it would say, how much of my products can I form? And you just leave both answers there. So that doesn't really show me that you know how to answer the question correctly, right? You're doing the work correctly, but are you really processing what the answer is? And so here it asks, how many of each product can I make? Well, I can make this much of my first product, and I can make this much of my second product, right? That's really how I'm going to have to answer that. Does that kind of make sense? This T-chart does nothing for us except help us identify the limiting reactant. Right? We can't make that much product.
How do you know when your answers?
When it asks us for excess reactant, I'm going to give myself some more room here. I'm going to run a chart that goes from my limiting reactant to what? My other reactant, right? My secondary or my excess reactant. So we're going to start with 43.4, right? We always start with our limiting reactant. And we're going to go and decide if we can use up all 43.4, how many grams of beryllium hydroxide will I use in that reaction? So I just erased my molar mass for lithium nitrate. Can you tell me what that is? Okay, and then that's to 1 mole. My mole ratio would be 2 moles to 1. Oh, I'm sorry. I just wrote the same thing over and over again. Okay, here we go. This one should be beryllium hydroxide. Molar mass here, 34. 34 plus 9 is what? 43, thank you. 43 grams. All right, so I got from that about 13.5 grams. And so is that my excess amount? Nope. This is the amount that is used. So I take my starting amount of beryllium hydroxide, 38.4. That's how much I started with. I know from my math I'm using 13.5. And so that means that I have left over 24.9 grams of beryllium hydroxide in excess.